All right, we are continuing in section 1.2 of Rosen, Discrete Mathematics and its Applications, and we are going to use the techniques for determining consistency of specifications to solve this problem 34. What we have here is a chat room with 5 friends that could potentially be chatting in the room, and we want to determine from these specifications if we can figure out who is chatting and who is not chatting. Well, first let's talk about the atomic propositions. Since each of the names has a unique um, uh, initial, we'll use that initial as the atomic proposition for whether that person is chatting or not. So we'll say that blank is equal to blank is chatting. That's what it'll stand for. And we have how many atomic propositional variables? We have 5 of them. K for Kevin, H for Heather, uh, R for Randy, V for VJ, and A for Abby. So if K is true, that means Kevin is chatting. If H is false, that means Heather is not chatting, and so forth. All right, so those are our atomic propositions, and since there are 5 of them, that means they can take on a total of 32 unique truth value combinations. 2 to the 5th is equal to 32. That means our truth table is going to be 32 rows long. Don't worry, we're not going to write it out by hand. I have it filled out on the next slide. But you can see how these truth tables can grow very fast. All right, so let's use our atomic propositions to write down our specifications symbolically. And we'll start with the first one. Kevin or Heather or both are chatting. Well, that's just going to be K disjoined with H. Randy or VJ, but not both are chatting. So that's going to be R, X or V. Next we have, if Abby is chatting, so is Randy. So we have an implication. A implies R. VJ and Kevin are either both chatting or neither is. So that means they have the same truth value. So V, if and only if K. And then finally, another implication. If Heather is chatting, then so are Abby and Kevin. So H implies A and K. All right, so these are our specifications. And in order to determine uh, who is chatting and who is not in our truth table, first of all, we need to determine if they are consistent. Is there any row where all of my specifications have a truth value for some setting of my atomic propositions? And in order to know who is chatting and who is not, I can only have a single row of all trues. So let's see if we can determine that. On the next slide, we'll have our atomic propositions and all of their possible values. Notice we have first column is half trues, half false. Second column is a quarter true, quarter false, quarter true, quarter false, and so forth. To the last column is true, false, true, false, true, false. All right, so 32 possible ways we can set the values for these. Now let's build a table of our specifications. And you see those going across the top. We have uh, K or H, R, X or V, A implies R, V if and only if K, and H implies A and K. And I have this intermediate column A and K to help me uh, calculate the truth value for the implication on the far right. And so first, let's just look at if we have all trues, if everybody's chatting, is that consistent with our specification? Well, K or H is true, but look, R, X, or V is not true because they can't have the same truth value. A does imply R, V if and only if K is true, and H implies A and K is true. But that doesn't work because we do have a false in that list. Well, if I move down one and I have turn A to false, I still have K, or H. I still don't have R, X, or V. A implies R is true. V if and only if K is true, but since A and K are now false, I have a truth implying a false in my application, so that's also not true. So we still have not found a row where our specifications are all true. I'll just go ahead and fill it out. And I'll point us to line 14 where we do see we have all truths for our specifications, and the settings that give us that are true, false, false, true, false for atomic propositions. So we can see that our specification is consistent. Can we tell if that is the solution? It turns out yes, because there are no other rows where all the specifications are true except for 14. So we have solved the problem using a truth table.